Greetings, everyone. Today we're going to be talking about A2 milk and unbiased view. Now, I've still got a few people down the side here, but that's all right. We can work with that. My name's Otter. I will get rid of all those and let's get started. Jenny has done the introductions, so it's up to me to do the talking now. What I thought I'd do today was present a timeline of A2. And you can see that along the top, and I've put it starting at 1993. That's when Professor Elliott from Auckland Uni, a paediatrician, first thought about, he was working with some island people and looking at their disease states and thinking, oh, there must be a tie-in with something. So that's, I think of it roughly as about 25 years ago. And at that time I was working at DRI, Dairy Research Institute, looking at whey proteins. And so I got pulled into helping with the beta casein, looking for HPLC mass spec methods to identify beta casein morphin 7. Right, at this stage, I've been in the dairy industry for ages. I want to say that I don't have any A2 milk shares. It'd be quite nice if I had bought them at the right time, but that's wasn't going to happen. And this webinar content has been collated from lots and lots of work that's been done over the years from lots of people. I haven't included everything, but I can give you more details if you need it after the talk. And I'm just going to present the data. I'm trying to be as unbiased as possible, one way or t'other. So let's get going. So when I talk about the beginning, this is when Bob Elliott first broke his hypotheses about A1 milk and that it was implicated in a number of different diseases, from diabetes, heart disease, autism, and schizophrenia. And that was a conference held in Palmerston North, which is where I was working at DRI at the time. And it caused a bit of a stir. So we've got to start with what is beta casein. Now, you're all dairy people, so I'm not going to worry too much about this slide here. The big thing with beta casein is it's one of the major proteins. You obviously know that from milk. Everyone knows how much protein is in milk. In goat, sheep, buffalo, and humans, we all have beta casein type proteins. They have a number of different genetic variants. And you can see down there about 5,000, 7,000 years ago, the A1 variant evolved. From what they can tell, A2 was there before A1. I think that's the way it goes. I could be wrong on that one. And if we look on
sorry to interrupt. Do you want to get your pointer?
Sure.
Thanks.
I'm sure I have my pointer here. Whoops. Go back. I'm trying to get the thing up the top. Here it is. There we go. On this table here, we can see the molecular mass doesn't vary much between the A1 and the A2 genetic variants. And that is because there's only one amino acid difference. Okay, but that one amino acid difference may be causing a lot of problems. We shall see. When we look at the frequency of the different genetic variants, the big thing here is that we have some cows that are mainly A2, and those are the Jerseys, the Ayrshires, the Guernseys. And then we have some that are pretty well half and half, and those are the ones that are mainly used for milk production now, such as the Holsteins. So in the US, for example, most of the cows are Holsteins. That's a mixture. There are some societies that have purely Jerseys or purely brown Swiss, which are very low in A1. So what is this variant? If we look down the bottom, we can see the variant is in one particular amino acid where you go from a his to a pro or vice versa. And we can ask, so what? That is, what does it do? The big thing is, if we come over to the right-hand side here, we can see that the particular molecule we're going after, the peptide, is called beta-casomorphin 7. So that's 7 amino acids. And it's to the left of this one change. And during digestion of the protein, the natural cleavage sites are between the val and the tyrosine and the isoleucine and the histine. And by having a proline instead of a histidine, you get less cleavage there. It's less prone to cleavage. So the big thing to remember here is that both A1 and A2 milk variants have the sequence there. And a lot of people get confused. They think, oh, the sequence isn't there, but it is there. It's just how it's cleaved during digestion. So that's very important to remember. So what does this beta-casomorphin 7 do? There's a number of different beta-casomorphins down here. You can see there are different lengths. They all have similar base amino acids, but they just stretch out a bit further. What are they? They're called opioids, okay? So they have a number of different functions within the body. Excuse me, just getting the notes here. And they're linked to a number of different, what should we say, diagnoses. Some they say are good, some they say are bad. So I've just listed a couple of there, linked to the human mast cells, linked to mucus production. They have a number of different places that they bind to in the body, the mu opioid receptors, and you can see those on the top right here. Now, beta-casomorphin 7, has it really been, can we see it? And some people say they have, and some people say they haven't. You can't. So that is still a bone of contention as far as I can see. Another big thing is what blood concentrations of beta-casomorphin 7 are required to have any physiological function. And we'll get a wee bit into that as well later on. So what did Bob Elliott do? He looked at this link between the amount of milk and particular types of milk that people drink and the incidence of different diseases. And I mentioned before diabetes, heart disease, autism, and schizophrenia. And what he got was he went through the different countries in the world and said, these countries, their natural population of cows are either A1, A2, or whatever. And then he did the epidemiological link up, and you can see that here. This one here is for diabetes, and this one down here is for heart disease. And sure enough, you could see some sort of trend, both there and here. And to be fair, those trends are better than a lot of epidemiological trends I've seen for some of the studies that have been looking at these things. And so he thought, maybe there's some link between beta-casomorphin 7 that can come from A1 milk versus A2 milk. So there might be some sort of opioid activity that is triggered by beta-casomorphin 7. There's the same graph again. He looked at all the 10 different countries, looked at their amounts of diabetes. He figured out, there could be a mechanism here with the beta-casomorphin 7. What you'll find with any epidemiological study is that, yes, they've even looked at completely irrelevant factors and done correlations and found some sort of correlation. So just because you have a correlation doesn't mean there's causation, and that's what I put down here. There's a lot of other factors that can be involved, and you have to be very careful with these things. What he did next was go through and think, right, what else can I do? He looked at a mouse study and he found, oh, I got an increase in A2 with A2 milk feeding the A1 milk, feeding the mice. I got increase in diabetes. That's in mice, it's not in humans. And from the study, I'm pretty sure the amounts he was giving were a bit higher than what you get in human milk. Did another repeat with A2 milk, but when that was peer reviewed, they didn't find any effect at all. So, excuse me, I'll go backwards. He's done some more studies. He also looked at cardiovascular disease. And again, when you do the plot, you can get lovely correlation. But again, there's lots of different compounding factors. There were another couple of plots that came through that had exactly the opposite conclusions. So at this stage, there's no real cause and effect type results that really solidify what Bob was really saying at the beginning. Boyd Swinburne, who's now over in Deakin University, I think he was in New Zealand at the time, he did a big study and he found that no, there wasn't really any really solid evidence to say that you should remove A1 milk from your diet. We could go through and look at autism as well. Can we use milk opioid peptides and correlate it to autism symptoms? There's one group that said yes, another group that said no. And again, there could be a possible link, but the evidence is very poor, very poor. So we're slowly going through his list and thinking, right, we've got these correlations with epidemiological studies, but when we do clinical studies, can we see any really big difference? Now, another Australian, Stuart Truswell, out of University of Sydney, also did a big review. His conclusion was no convincing or probable evidence that A1 in cow's milk has any adverse effect on humans. This is 2005, so we're talking now, we've gone 10 years after Bob first put up his theories. We still don't really have any really good human clinical studies. We've got a few minor ones. We've got a few using animal models. So where does that leave us? 2007, Keith Woodford, who's a lecturer, a prof down at Lincoln University, he was a great advocate of some of this work. And he published a book called Devil in the Milk. And that sort of stirred up the hornet's nest again. And again, he was highlighting the diabetes and the heart disease links. mainly again showing the high intake of A1 milk leads to higher incidence of diabetes and heart disease. But again, because of all this, the New Zealand and the Europeans got together and thought, right, we better do a study. So they asked Danone and Fitzgerald, and there's a big group in that, to do a review for the European Food Safety Authority. And they specifically were looked at just disease, any disease at all. Their conclusion was, based on the literature, there's no cause and effect established. And so they declined to do a formal risk assessment. They said it wasn't validated to have to do that. So again, we're up to 2010 now, so that's only 10 years ago. 15 years has passed. In the meantime, A2 milk has come up and they've got product out into the marketplace. It's selling at a premium and it's selling really well in Australia. I think in Australia it got up to 8 to 10% of the liquid milk market. Why was it selling? They had a story to tell. So, where do we go to from here? What some people were asking was, okay, we have milk. We know it's got either A1 or A2 beta casein. We know you can get beta-casomorphin 7 from the milk. Is it actually released though? So what happens in the GI tract? What happens in the stomach when you have the milk being hydrolyzed? It's got acid there. Can we actually see any of this? Theory is brilliant, but what can we see in the actual milk itself? So what they did was just use pepsin and GI enzymes in a simulated system. And if we show here, if we go down to pasteurized milk for a start, if we have A1 milk, A1 milk, sorry, once it's been hydrolyzed, yes, we get up to 350 nanograms per mil. Now, half of that is roughly 200. So that's pretty good if you have A1, A2 milk, the mixture of the two. What they still found was they got about 10%, even with A2 milk. So you do get some cleavage there. You get similar numbers also with both sterilized milk, and that's higher than 10%, and milk powder. Okay, so that's almost 15% there. So, well, it's over 15%, sorry. Yes, so that means in a simulated system, you can get beta-casomorphin released from the casein protein. And that works for both A1 and A2, but obviously there's a lot higher in A2. So the question you're all asking me now, and I can hear it, is what is the amount that you need? If it's released into the stomach or into the gut, A, is it absorbed? And B, what levels do you need? Are these 300 nanograms per mil, is that relevant to anything? Also, they were looking at other systems. So this Danone, he was part of the EFSA review. He's out of Milan, and they did their own got their own simulated system. They got 600 milligrams per kilogram, which is almost twice what we had in the previous one. But again, this is in a simulated system. What happens in the real world? What happens inside us? He says, clutching his stomach. There's a number of different proteases involved in the stomach that they didn't use in the studies. One of them, peptidase, cleaves beta-casomorphin 7. So just because it's a peptide, it doesn't mean it can't get cleaved further down to smaller peptides or amino acids. And this is one of the cruxes that we haven't really solved yet. What is really happening? The other thing that people haven't looked at this stage is, what about the other beta-casomorphins? So 5 years later, Danoni did another study, and in this case, he looked at cheeses. Now, when we make cheese, we use a starter, we do the cleavage, and then we do the ripening. And during the ripening, there's lots of different bugs around that are producing proteases that can have different flavors. And the flavor profiles come from the breakdown of the proteins, well, and also the lipids, obviously. So would we expect to see any beta-casomorphins in cheese? So sure enough, they did that to have a look. And if we come down to the bottom left, they looked at 12 different cheeses. They matured them for different times, and you see the times in the brackets, from half a month through to a year almost. And then they looked at all the different beta-casomorphins. Now you can see some of them, the 3 and the 5, there's very little of those. 4 and the 7s seem to be the most prevalent. And of those, 7 is the most prevalent of them all. So yes, you can get beta-casomorphins produced in cheeses, and that's just during the production. Right, so what happens to those beta-casomorphins after you then put them through a simulated system? They looked at both the 2 levels, one the gastric and the other intestinal, to see what happens, and they just chose 4 different cheese types. And if we'll just stick with the beta-casomorphin 7 here, in groups of 3 as we go down, after the gastric, you don't really see much. Intestinal, you go from 0.14 to 0.12, 0.18 to 0.124. So for 2 types of cheeses there, they stay roughly the same and are fairly low. For the other 2 types, you get a drop as well in gorgonzola. For the cheddar, you actually get an increase, about a 5-fold increase. Again, this is in vitro, not in vivo. And are those levels of any significance? And can the beta-casomorphin 7 go on from there? One of the other things that they looked at was, if we have this production of beta-casomorphin 7s, or the opioid peptides, what else can they do? The EFSA study sort of knocked on the head the idea of the diabetes, the heart disease, etc. So people started thinking about what else could be happening here. And A2 was still looking for a story. So there were some rat studies being done during the early 2000s, and they looked at transit time in the intestine of the peptides. The transit time of your poos in your intestine. they found there was a change. It slowed the passage rate. Now, that could be good, or it could be bad. As in, if you get too slow, you could drive too much water out and you could get constipation. But if you have someone who has diarrhea, it could be good because it slows it down. It acts as an anti-diarrheal. So there's both a good and a bad involved with this. But this is using beta-casomorphin 7 in a rat study. It's not doing it in vivo, and it's putting the beta-casomorphin straight into the rat itself. So yes, you can see a change in the intestinal transit time, but again, what does it mean? Colleagues at AgResearch, which is similar to your CSIRO, but the New Zealand equivalent, they got on board with A2 and looked at this altering the digestion. They looked at gain in rats, not in humans, and showed that yes, you do get the slower GI transit with A1 compared with A2, and also that it could be eliminated with a drug that blocks opioid function. So that to them implies that yes, it was caused by a beta-casomorphin, probably beta-casomorphin 7. Woodford from Lincoln, he teamed up with another group and they fed A1 and A2 milk to humans. This is probably one of the first human trials that I could find. And then they looked at stool consistency. And yes, statistically, they found a difference in stools from A1 to A2 milk. When I looked at this, I thought 3.9 versus 3.6. It's a 10% difference, but the stool scale is from 1 to 7. So I thought, is that really significant? And also I thought, well, the normal in a normal human off that scale is 4. So both of them weren't really far off being normal. So stats, for me, stats has a lot to do with this. There was no difference in bowel frequency, no difference, or significant difference, sorry, in bloating and other factors. So yes, you got a difference, but was it really relevant? They also, in the same study, looked at inflammation, but there were not a lot of evidence looking at the inflammatory markers. And even though it was stated to be a preliminary study, the data didn't really back up too much conclusions. Now, this was an independent study done in India where they looked at a number of different inflammatory responses in the mouse gut, and they used the Th2 mediated responses. With A1 versus A2 versus A1, A2 milk, they did find a lot of different levels in a number of different markers for inflammation. They also found some that weren't changed, and they found some that were, some messenger RNA expression was also changed. So in the mouse gut, they could say, yes, we did find changes. Again, you're talking about mice or you're talking about humans, but that was a good, well done study. A2 got back into the action where they did a study over in China, and they've done 3 studies in China, mainly because they want to go there as a marketplace. And also, I think, because at that time it was easier to get studies done in China using human intervention. The problem with any Chinese study is the Chinese don't really drink milk. And most of them have some sort of lactose intolerance. So they chose 45 Chinese Han. They all said they were lactose intolerant. When they did the urinary galactose test, only half of them tested positive for lactose intolerance. After drinking A1 or A2 milk, they talked about a delayed gut transit, which we sort of already knew about. They looked at inflammation, and there was a change in inflammation, but not a high level of significance. And they also mentioned worsening digestive discomfort and cognitive. They looked at cognitive function as a measure of basic dysfunction, basic dis-ease, shall we say. Most of the symptoms were attenuated by the elimination of A1, which means they went down lower. But the power of the test of the whole trial wasn't great. And they came out with the suggestion that, yes, there was something there, but it was only a preliminary trial and there was no cause and effect proven. This was followed up soon after by 600 people, again, self-reported lactose intolerance. These studies have been very well designed, crossover, double blinds, randomized, etc. So the way they were performed, you have no complaints about. The GI symptoms, when they looked at them, for me, it was funny the way they reported them. They reported them as a median. So the range was between 0 and 9. They reported medians and ranges, but not means or standard deviations or anything like that, which I found rather bizarre. They also did a comparison. They really compared they used A2 as a marker and they compared A1 against it, which, yeah, I didn't think that was the best way of going about it. They found slight improvements in the GI symptoms when they consumed A2 versus A1. But I found the treatment interventions and the way they evaluated the difference were very problematic. Having said that, they did get some slight improvement with some of the lactose absorbing malabsorbers with A2 versus A1. And by slight improvement, I mean you're going from, on a scale of 0 to 9, you get maybe a 1 or a 2-fold difference. And this is where the numbers they only worked in whole numbers, and it just seemed it's not how I would report a trial, and it seemed almost as if they were trying to hide something. I shouldn't say that, but this was another interesting one that I found, and there's no details anymore. And I don't know if it was through A2 Corporation or not, but there was a Chinese medical forum, Dingxiangyang. Apologize for my Mandarin. And this was inviting doctors from around the world to participate in the trial, and 97% of them believed the GI discomfort disappeared or subsided. This is just more anecdotal than anything else. About the same time, A2 went over to the US, and I have to say at this stage that between 2015 and 2018, I had 3 years in the US working in a university over there. So I was there as A2 milk was being introduced, and I got a lot of people asking me for my opinion on A2. It was, as in today, I'm trying to be as impartial as possible. And I was quite amazed at the response from the American dairy people. They were more intrigued. They didn't really care too much about what they were trying to say. They were intrigued, A, to say, right, how can we change our herds just to get to A2 milk right from the word go? If there's something there, we want to be in on it. And the other one, which I thought was really very different to what's been happening around other parts of the world, like down where we are, is that they said, we don't really care about A2 milk if it keeps people drinking milk and it makes more people drink milk. Good on them if they want to pay the 20, 50% extra. I'd like to see the science. It'd be good to be involved with the science, but at this stage, if we just keep people drinking milk, that's what we really care about. And it was about this stage I got involved working with Dave Dallas over in Oregon, and he's going to be starting up a trial, I think, this year, depending on funding, to do some more work on the human side of it. So that'll be interesting to see how that pans out. What did A2 do over in the US? They went into Louisiana, into the state university there, and they were supposed to be doing a study, but I have not been able to find anything on it, sorry. All I found is they've produced a replacement drink powder, and you can see them doing it there. They're marketing it for people who have digestive issues, and it's for weight loss. And weight loss in the States can be quite big. So I was a bit disappointed. I thought they were supposed to be doing a big trial, but to date, I haven't been able to find anything about it at all, sorry. What else have we got? As we move further along, we're getting very close to home now. And this is one that I found, which I thought was quite interesting. Bifidobacter. We've all got Bifidobacter inside us. What does it do? It's a dominant bugs in infants. It's got peptidase activity. And what they've found, this group, this is out of Morinaga, which is a dairy company. In infants, they naturally degrade beta-casomorphin 7. So that sort of begs the question. Yes, we can get beta-casomorphin 7 produced, We know it's an opioid peptide. Does it only affect, or is it the effect attenuated or enhanced by babies with a dysfunctional gut microbiota, i.e. they don't have the bifidobacter there? No one's done any work on that, but I thought, oh, that's quite an interesting question. Now, another group in the US, going back across the ditch, is Purdue University. Dennis Saviano, I said that wrong too, Saviano, sorry. There was a lot of ballyhoo about, yes, he was going to be doing some work with A2 Corporation as well, doing a big study. Nothing has been published on that, but I did find a master's thesis. Again, randomized double-blind study, which is good. In this case, about this stage, about 5 years ago, when they started talking more about comfort. What is A2 good for you? Sorry. They moved away from Bob Elliott's 4 main diseases to more to can you drink milk and does it cause a discomfort? So they've got this whole message, different message. So they looked at normal regular milk, which is A1, A2. They looked at A2 milk, Jersey milk, which is again is mostly A2, and lactose-free milk. Looked at the lactose digestion, maladjusters and the maldigesters, sorry, and used H2 breath test to measure the malabsorption. For milk intolerance, they used questionnaires. I felt a bit sorry for them because the poor guy who was doing this master's thesis, he only ended up with 7 people. And the power of a 7-person study is pretty minimal. So he could only say, yes, we strongly suggest greater hydrogen production from A1 milk compared with the other 3. And the GI symptom scores were lower in the lactose-free pure A2 in the Jerseys, but there was no significance at all. And when they looked at the power of the test, got the statisticians onto it, they said they would have had to have at least over 26 people to really get some decent numbers. So I hope they're doing something. I hope they're getting trying to get something out there. Okay, and then we come back over to China. This is another study by A2 Corp, looking at 75 different preschoolers. One thing we have to say about these different studies as well is they're giving the participants different amounts and different durations of milk. So here they're giving these 5 and 6-year-olds 2 lots of 150 mils, so that's half a glass twice a day for 5 days. That could be problematic for people that don't normally drink milk in the first place. That could be problematic if you have any lactose intolerance, or even, well, if you don't drink milk. They had lower scores amongst the lactose intolerance people for the GI symptoms. For the lactose tolerant people, they had some varying responses. For me, I wasn't convinced about when you look at the graphs and you look at the significance. It's a nice story, but no. I guess it has to do with the people they selected, the kids. A lot of it is questionnaires. How do you get a 5 and 6-year-olds to do a really good questionnaire? Serum biomarkers, they had good changes there, and they were significant. So yes, there could be something there. But again, I thought there was maybe just too many confounding factors. Then we come up to last year, a rat study. In this case, they're saying beta-casomorphin 7 might actually have a beneficial effect on reducing inflammation. And the problem with all these things is the dosages. What do they mean? Do we get the same amount of beta-casomorphin 7 in humans? And can we really translate it to humans? Now, in the last couple of years, Ag Research and Auckland University have been doing a lot of different studies. They've got a lot, not a lot of money, but a bit of money from the government, which is being co-funded by A2 Milk. There's just a number of different papers there, and you can read those up. Most of these are, the first 3 are just abstracts for meeting talks. The last one is just about an analyzer. That's not that important. But they did the final study using 40 females, 20 that were basically tolerant to milk, some that were reported intolerance, randomized controlled trial like they all are. What do they get? When you looked at the lactose malabsorption and the digestive comfort, the A2 milk, it improved it slightly, but not significantly. And for a lot of the other factors that we're looking at, like the abdominal cramps, rumbling, etc., there wasn't a lot of difference between the two. Now, I've talked to people from Ag Research. They say that they're not going to be doing any more studies. They couldn't tell me. I asked if there were any other papers coming out, and they said, yes, there might be. I'm going to leave it there. I can't say anything else. So, bottom line, where are we with the whole story? We've got lots of studies. I think it was ruled out pretty early on about the heart disease, the diabetes, autism, and schizophrenia. Yes, we know beta-casomorphin 7 is released in higher amounts from A1 milk to A2 milk in vitro. In vivo, we're not sure yet. Those studies haven't been done. Not sure how you could do them that easily. Inflammation, there's a little bit of evidence, but not much. Constipation, again, we know the transit time changes, but we need a bit more funding. And I'll put there non-biased funding. I'd like to think that all the people that are doing the A2 funded studies are non-biased. They tend to publish in open access journals, and I've looked at some of those, some of the papers. You can actually go in and look at who the reviewers are. And I was a bit disturbed in that some of the reviewers were all people that had A2 funding. So in one study, I think of, I can't remember how many reviewers, over half had A2 funding, which for me doesn't sit well, shall we say. So anyhow, consuming A2 milk, is it problematic? No, go for it. It's not a problem. A1 milk, if you can, yeah, doesn't worry me either. Yogurts, kefirs, stuff, other dairy products. What's the difference between A1 and A2 milk? There's a little bit of work on yogurts, but there's still a lot of work to be done on that yet. I think that would be quite a good study. What happens in the adult gut? Does it get absorbed into the body? How long does it stay intact? I mean, these are just brilliant questions that we don't know the answers for. Are there different consumers for A2 and A1 milk? Again, anecdotally, yes. You may, if you get diarrhea from drinking milk, you may change it if you have A2 milk. Who knows? But there's still a lot of questions out there. Now, I mentioned A2 Corporation have changed their claims, no longer make diabetes, etc. claims. Now they're using very soft claims, easier on digestion, may help some avoid discomfort. I can understand why they're doing it. They've got a good position. They really want to have some good numbers though. They wanted some good science there, and it's not quite there yet, sorry. And at the same time, look what's coming. This came out, I saw it just this week. Over in the States, Gerber Good Start A2. So it's A2 milk. It also contains probiotics, contains human milk oligosaccharides. It's got everything. Who owns Gerber? Our mates Nestle. Now, here's a whole lot of references for you. I only just skimmed the surface, sorry. I haven't had time to go through everything. There's a lot of things there, 2 pages of references, and I can give you more if you want them. And with that, we'll open for discussion. And when we do that, I have to go into more.
Okay, so if you can type your questions in, folks, that would be really good.
Ooh, what happened here?
Just click on that on your screen again, and
oh, there we go. I'll come back in here in case people want.
Thank you. That's good.
Oh, look, I did the same thing again. I'm trying to get that little bar up the top. Here it is. Chat. 7 questions. Right, let's go. Let's go. Where do we start? 4 o'clock, 3 o'clock. I can see Don, me too.
Oh, yeah, well, sorry, we need some questions typed in. So, I'll just give you there a minute. I'm sure we'd have some questions coming in. Can't have all that information and no questions. Here we are. Don, can you see that one?
Rolling down. Can you provide a bit more information on the studies coming through about yogurt? The yogurt ones, what was her name? Yes, is the answer. Yogurt is compounded because you've got all your bugs in the yogurt as well. I can give Jenny some more references for that, but I've only found one study, and I think we need more studies on it before we get too carried away on that one. That was from an Australian group as well, if I remember rightly. I'm very...
Right.
Any other questions?
Yes.
Lots of, yeah, give the cows given the cows are the same, just selected for the protein, what are they? Well, this is brilliant. A good question, because...
Can you read out the question properly, please?
Sorry. Lots of detail. Given the cows are the same, just selected for the protein, what the significant price difference? Is this due to yield from the breeds or volumes produced? A2 have purposely placed their product as a premium product, and they're working on the basis if people want to buy it, good on them. There's no, the cows are just normal cows. They've just been selected for the A2 variant of beta casein. What I said to the dairy industry over in the States and also in New Zealand about 20 years ago is it would take us 5 to 10 years to convert all the cows in New Zealand and in Australia over to A2 without any change in milk production. It's easy, very easy to do. A2 Corporation had the patent for testing whether a cow DNA was A1 or A2. So they tied it up a bit that way. I developed a HPLC mass spec method for doing the same thing. So nowadays you can find out what genetic variations individual cows give, and you can easily select for A1 and A2 milk. Sorry, I'll come back down. When we have marketing like this, does it not run the risk of discrediting traditional milk and potentially detract from the inherent good in milk? This is a philosophical question, and that's why I like the Americans' response, where they say, well, the Americans took them to court pretty soon after they got there about their claims, even though they're very, very soft claims, to say you can't say that. But at the same time, they're happy for them to be there if they're increasing the volumes of milk that everyone drinks. Whether it detracts from the inherent good in milk, what I always ask my students is, why do we drink milk anyhow? It's designed for calves or babies. We're grown people. Why do we drink it? I mean, I'm in some ways I'm sort of being facetious, but I'm just pushing them to say, what's in milk? Why do we drink it? Etc. Etc. I don't know that detract from the inherent good. Yeah, I think a lot of people can see that they don't really have a strong case for making really good claims. They're just very soft claims. Great presentation. Next question, sorry. Great presentation and array of slides. How do companies make such claims without substantial evidence, especially in human studies? Again, they've been very careful with their, let's get out of here, with their marketing. Easier on digestion. What does that mean? May help some avoid discomfort. What's discomfort? They've had their legal eagles look at this and say exactly what they can and can't say, so that they don't get prosecuted. Even around the big A2, they've got the A2 milk company feel the difference. It's sending a message out without saying anything substantial. Don, how come the claims are not challenged more by regulators? Because they're fuzzy. Simple as that. So in a lot of ways, they are marketing to the wealthy well, if I can say that. But at the same time, as a scientist, there are some things out there that maybe are good. We can't poo-poo all the evidence. And as the Americans say, well, if someone who hasn't drunk milk drinks this and thinks, oh, it's good, I don't get any complaints at all, I'll keep drinking it and I don't mind paying the premium, well, good on them.